It's nice to be here. You're going to hear some more about California State Fair wine scores. So the question we're looking at is to see if there are there's an association between the consistency of judges and some other factors of either the tasting itself or the wine. So these are data. This is work with Jing, my co-author, and we thank Bob here for providing this data to us. Okay, so I don't think we have to linger here. We all know that wine quality is an abstract measure, and so there's been quite a bit of written about how the scores assigned to wines are quite variable. And so what we wanted to look at is whether this variability is predictable. That's the idea. Are there some types that are more likely to cause problems for the judges than others, or other factors of the tasting itself? So our goal was to investigate the association between the judge agreement and different factors. So rather than focusing on the variability, we're focusing on the sort of the opposite of the variability, which is the agreement. So we're looking at the association between a measure of agreement and different factors that include the wine variety, but also the flight size and the time of the tasting. So this is, again, the California State Fair data. So this is just some characteristics of the judging of the California State Fair and how we transform the data, but Bob has already talked about that. So we also took the no award, bronze, and so forth into numerical scores from 80 to 100. And then we looked at the flights and the data assigned to each wine. So we have data, an example of the way our data came to us, or the way we transformed it to look is this. So the rows are the wines and the columns are the judges' scores. And we investigated then a measure of association called an intercluster correlation. So it's based on a random effects model. This is a random effects model where the alpha I is the random effect for the wine, and beta J is a fixed effect for the judge. So we let the judge's sort of average point vary if it needed to in our model. And then we had this noise term that captures the variability that's not associated with the wine. And so then one of the measures of association is intercluster correlation, which is defined as the proportion of the variability, the total variability in the scores that's due to the wine. So the denominator is the total variability of the scores in the competition, and the numerator is the amount of that variability that is not noise. So what you want is an ICC, well, if you want good judges, what you want is an ICC score that's close to 1. So you can sort of think of it as a correlation, except that its scale goes from 0 to 1, where 0 means that all of the variation in the wine scores is due to noise, and 1 means that all of it is due to judges. So we calculated the intercluster correlation for all the flights, of which there were 114, and this is the histogram of the ICC scores. So the highest score was not quite 0.5. The lowest score was actually negative because of I just finished saying that ICC can only go as far down as 0, but in fact, the vagaries of statistical estimation let some of them go negative. But that basically just means that there's no evidence of any consistency. So this is our histogram. So you can see that the ICC scores are, there's kind of a wide range, and that they're not all that good. So that's the main thing from this slide. So the average ICC is around 0.15, meaning that about 15% of the variability in the scores is due to the wines. The other 85% is due to something else. And it's quite variable, so some are better than that. So then what we did was we wanted to see if we could find any structure in those ICC scores. So this time we let the dependent variable, y, which this thing seems to be not working anymore. Anyway, y in this regression model is the ICC, and then we have a number of predictors. So the beta 1, the x1 is a set of, it's actually not a single variable, it's a set of indicator variables for the varietal. There were 9 different categories that we used. So the reference category is Merlot, when you look at the results in a minute, and then all the others we estimated in comparison to Merlot. The second predictor there, x2, is the flight size, where again we categorize this into 4 categories: less than 10 wines in a flight, 10 to 19, 20 to 29, and 30 to 39. In this case, the reference category was less than 10, so when you see the results in a minute, everything is in comparison to the small flight size. And then the other 2 factors are actually not, they're indicators, they're single variables. X3 is whether or not, it's a 1 if the flight is the last one and evaluated in either of the days of the competition. And X4 is whether the flight is evaluated in the second day. So all these are indicators. There's the last 2 are single indicators, time of day and day of competition, and the others are a bunch of indicators for size of flight and type. So these are our results. There's a lot of numbers on this, and I'm really sorry I don't have a pointer anymore, so I guess I have a finger, so I can point to it.
Is the top button?
That's what I'm doing. It doesn't seem to be working, but anyway, I can point. So you can see that mostly we found nothing, but there are a few points that maybe you guys can help us decide if it's important or not. So we're looking here, for those of you who don't run regressions all the time, for small values less than 0.05 or so. So many things that we might have thought would matter don't matter so much. But what we found on the varietal is that it looks like, what is that? Petit Syrah has an effect, and it's positive, meaning that the consistency is greater for this varietal than for the others. We arranged this may help you interpret. We arranged the model so that everything positive was in the indicators, and the reference category was the worst. So whenever you see a significant variable, it means that that particular indicator, it has higher consistency. So anyway, Petit Syrah was 1. This one's sort of marginal, Sauvignon Blanc. This is the other category. I'll talk a little bit about it. That's just a dump of everything else. But we do have significance on size. Now remember, the reference category is the small flight, and then the second day seems to have a significant factor. So let's look at interpretation of these. Now this doesn't even work. There, okay. So this is kind of a repeat of what I said. Petit Syrah and Sauvignon Blanc seem to be associated with more agreement. They were significant in the positive direction. However, both of those varietals had fewer flights. So in other words, there's less information about those than the others. That, however, doesn't explain why it would be small, because even with, what it means is that since there's so few, when they are significant, they had to be even greater. So actually the effects, if you look at the magnitude of these differences, it means that this one has actually the largest effect on ICC of anything. So means that the ICC was 0.179 greater for Petit Syrah than it was for the reference wine, which was Merlot. So since the average is only 0.15, that's pretty large. And that's why it was significant, even though there was only 5 flights. Is that what I said? 5 flights. no, 4 flights. And Sauvignon Blanc, the other one that was significant, had only 5 flights. Again, don't know if that's anything statistical. It doesn't seem like it should be, or if there's some other interpretation. The other significant wine category was the other category, which actually contained about 20 different wine types evaluated in 42 flights. So there's a lot of variation in that category. So I don't know exactly. Some of the highest judge agreement was of any, as measured by ICC, were for some of the subsets of this group. But there just weren't enough individual ones to treat them all as a single effect, so we put them all together. In general, there's no huge evidence that wine variety affects judge agreement, especially among the ones that had a large number of flights. Am I supposed to be pointing this back there? Do better. No.
Clicking it all?
Where am I supposed to be pointing this thing?
Well, I think probably there.
Oh, okay, there. Good idea. Okay, as for flight size, remember that the reference category was the small flights, and so all 3 of the other size categories were significantly positive, meaning that all flight sizes, large ones, greater than 10, had better consistency than the small ones. And they were, among themselves, the 3 categories that were larger than less than 10. I would try to go back, but I'm sort of scared to try that. Let me see. Okay. Among those, there's not very much difference. So these are not actually significantly different from each other, but they are all different from the small ones. So I think we can say pretty clearly that the data suggests that the small flights have less consistency than the large flights. Now, whether that's due to size or whether it's due to something different about what kinds of wines end up in small flights, this data has nothing to say about what the interpretation is. Whoops. And so then we are going to look at the time of day. So the judge agreement in the last flight isn't lower compared to the earlier flights in the day, so that effect was not significant. However, the second day as compared to the first day, the consistency was quite a bit higher. So had quite a small p-value. In fact, that was the largest effect in terms of significance, not in terms of the size of the effect. So let's go back and see how big the effect was. Yeah, so it's 0.07. So that's 0.07. So for the last day of the competition, the average ICC went up by 0.07. So when you think about the fact that the average is only 0.15, 0.07 is quite a large change. Oops. Okay, so it doesn't seem to suggest, at least, that there's something that fatigue is a factor on the second day. So this is just a summary of what I've said. We didn't find anything too exciting about the difference in the varietals. We did find that flights of small size are associated with lower agreement, and there wasn't much difference other than small. So it didn't seem like the large flights made people worse in terms of consistency. And doesn't appear that fatigue is a factor either. In fact, maybe fatigue makes you better if there's anything that changes, or maybe it's practice instead of fatigue. So anyway, taken together, the study provides some evidence that the inconsistency is really not something we can parse out into a cause, too much of a cause. There is a little bit of evidence that there's something about the way the judging is arranged, but there's still a lot of intrinsic variability even if you try to isolate it. So that's my